Hi there. We are starting Unit 5, and Unit 5 has a lot to do with triangles and properties of triangles and how to put things in order, Pythagorean theorem, many different properties of triangles. So, triangles are classified by sides and angles, and we're going to get to that tomorrow. But what we're going to do today is talk about how triangles are listed in order from least to greatest, how many degrees are in a triangle. That's going to be the main focus of today. So the first thing we're going to do is list sides from least to greatest. Now basically what it is, find the shortest side, that's the smallest side. So in this case, AT right here is going to be the smallest side because it has the smallest measure, AT. And then the second smallest sides would be AN, and the largest side would be NT. Over here, same thing, look for that smallest side, it would be AB. I almost put 9 there. AB. Next smallest side is BT, and the last side is 11, which is AT. The same concept goes with angles. So we're going to list these angles in order from least to greatest. So you always find the smallest measure, which in this case was angle A. Next one would be angle N. And the last one is the largest one at 75 degrees, which is angle T. Example 4, here's same one, angle A happens to be the small, oh no it's not, angle T is, I apologize. Angle T is the smallest, angle A is the next smallest, and then angle B is the largest at 90 degrees. You may be thinking, wow, that's so easy, but guess what? There is a catch. Make sure you read the instructions very carefully because you may have to put it in the opposite order, or I may give you angles and I may tell you to put sides in order from least to greatest, like here. So what we're going to do is I give you angles in this triangle, and what I want to do is I want to put the sides in order from least to greatest. Those correspond with the angle measures. The smallest angle measure here is angle A. What side that corresponds to that is the side that is across the triangle from that angle. So NT in this example is the shortest sides. Remember, never judge a triangle by the way it is drawn. In the next triangle, the middle one is 66, so you go across the triangle there. AT is the second longest side. And lastly, the one that has not been used yet is 75 degrees, and you go across the triangle. And NA is the longest side. And in example 6, it says put the following angles in order, and I give you sides. Now, just like the problem before, the side measure corresponds with the angle measure. So the smallest side here is 9. So you're going to go across the triangle. Angle T is going to be your smallest side. Smallest angle, I apologize. Here we have 10 is the next one. You're going to go across, so you have angle A. And lastly, 11 is the longest, so you're going to have angle B. Another thing we need to know is try to find out if your triangle is actually a triangle, or is it just 3 sides that don't connect. In order to tell if it is a triangle, you must compare all 3 sides. So it says, can the triangle have side lengths of 5, 7, and 10? So what you're going to do is you're going to take 2 sides, add them up. Those 2 sides must be greater than that third side. Well, 5 plus 7 is 12, and 12 is greater than 10. Do you agree with that? That's true. Then you're going to take 2 more sides, 5 plus 10, and those have to be greater than the third side, 7. 5 plus 10 is 15, which is greater than 7. That's true. And lastly, 7 plus 10 has to be greater than 5. Well, that 17 is greater than 5. That's true. Since all 3 of those are true, you have made a triangle. So this can be a triangle. What about 5, 8, and 3? Okay, so 5 plus 8 is greater than 3. That's true. Then you have 5 plus 3 is greater than 8. Well, 5 plus 3 is 8. Is 8 greater than 8? That's false. So in this case, no, this is not a triangle. The next example we have is, it says write an inequality that describes the possible length of the third side of a triangle with two sides lengths of 16 and 9. So what we're going to do, this is actually pretty simple. All you're going to do is you're going to add the sides. If you add the sides, you have 16 plus 9, and you get 25. If you subtract the sides, then you're going to always take the biggest number, 16 minus 9, and 16 minus 9 is 7. If you put these numbers in an inequality, that means that third side has to be greater than 7, not equal to, but greater than, and it has to be less than 25. Anything over that, it's not going to become a triangle because it's going to throw off the whole thing. And lastly, it says, is the following vertices a triangle? What you're going to do is you first have to use the distance formula. The distance formula, excuse me, if you remember, is x2 minus x1 squared plus y2 minus y1 squared. So we have to do this with all three sides. We have LU, we have LV, and we have UV. So I'm going to take a second, pause the computer, solve these really quick. If you want to do the same, you can pause, and then we'll come back and we'll talk about, is it a triangle? All right, welcome back. So if you noticed, all three sides of the triangle were found their distance. Now you're going to have to find to see out if it is a triangle. So that means you have to add together two sides. So 7.3 plus 8.5 has to be greater than that third side of 9.1. So 7.3 plus 8.5 gives you 15.8, and that is greater than 9.1. Let's try another one. Let's do 8.5 plus 9.1. It has to be greater than 7.3. So here we have 8.5 plus 9.1, which is 17.6, and that's greater than 7.3. So that's a true statement as well. The next two we are going to try are 7.3 plus 9.1, and that has to be greater than 8.5. So again, 7.3 plus 9.1 gives you 16.4, and that is greater than 8.5. So this is a triangle. If you need help, please come in for extra help. Otherwise, have a great day.